Hello people, I've done another experiment with ML agents, and in this experiment I've come up with a way for having my little orange agent move around on a platform with holes in it to avoid the holes and reach a target. I've just been going through doing some practices with ML agent little by little, making it more complex. So in this latest one, this is kind of what I got going on here. And this is right now a trained agent. And as you can see, they're all kind of moved to the orange thing without falling in the holes. So it trained pretty well. And I'm just going to explain what I had done to get this to happen. Um, let's just take a quick look at the source code to see what are the observations I give to the orange cube. So here's my class. Some variables that are in the inspector window. I have the percent. Let me make this bigger. I have the percent of holes in the floor. I have a prefab for the floor, so it could make these little floor tiles. And the size of the floor and the move speed, how fast the cube moves. And then some private variables. It's I just need to know the bounds of the floor and the agent. I need to know what the target is that it's going to aim at, and the ray downlink. So yeah, the ray downlink, that's part of what I was doing. I used CollectObservations this time instead of the ray perception sensors in 3D. I'm just trying something new and different. So we can see here that here I'm looking at the prefab of the scenario, and what are we going to show here? That I have a total of 14 observations that I send in, and for the history of observations that are sent in, I kind of put it all the way up to 24. And then for the outputs of the neural network, I have them to be continuous, and there's two outputs, one for movement in the x-axis and one for movement in the z-axis. See, basically moving across the floor. And I also tried using, when I was doing the training, I tried using my GPU instead of my CPU. It does go a little faster, the training. Okay, so then back in the code here, on the initialize, I just get some of these variables, and I have a function called makeFloor that, places the tiles and randomly leaves the holes. Then on every episode's beginning, I make the floor. Okay. Then on action received, it just takes the two actions that I just mentioned, the x and z-axis movement. So vector action 0, it's a float, and that's movement in the x-axis. And vector action 1, that's going to be movement in my z-axis. Okay. And then every time I do a movement, I just do a check to see if the cube is off the floor, which would be I consider off the floor if I scan down from the cube and there's no floor beneath it, Now when I collect my observations, I use the ML agent collect observations. I override that, which it gives me a vector sensor. That's an object that has, that's how I could tell the ML agent what to look at. So here I just make 4 ray casts down from the corners of the cube, and the result of the ray cast are that it either hits the floor or not. So those are 4 booleans. So I add an observation of the booleans, and a boolean is just one value each, right? So that's +1, +1, +1, +1. That's 4 for the floor feelers. And then I add another thing I give it is the position of my agent. That's an observation I give to the neural network, and a vector has 3 values. Then I give it the direction from the agent to the target. I figured that'll be useful. So I normalize the transform from my agent to the target, and I pass it that. And then the last thing I give it is the position of the target. I figure those are the things that it would need to be able to learn how to move to the target and avoid the holes. So that's a total of 13 observations. And did I put 13? No, I have 14. Oops, that means I had an extra one. Then, a good thing to do when you're doing these ML agent training sessions, before you actually run the training, is to make sure that the controls work, where you control the cube yourself. So that's why I have the heuristic function here. And this is where I get to say what the actions are going to be instead of the ML agent library. So first I clear out my 2 out actions for the x and the z-axis, and then I just use the arrow keys to set the actions. And I just use whole values of -1 and 1. And we're almost done here with the function explanation. This is to make the floor. This isn't really about the ML agent. This is just some code that made the floor. You can see this code if you want when you get the source code. The link will be in the description. And then here's off floor check, which I just cast one ray cast down from the center of the orange cube down to see if it's over the floor or not. And if it's not over the floor, then I'll give it a fail. So I'll add a negative reward of a small value, and then I'll end the episode. And then to encourage it to keep moving, I give it a very, 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 very small reward to keep moving, so to avoid it from just staying still. You know, maybe I didn't have to do that, but it seems to be it seems to have worked really well. And then for the success of the training, I just have to see if it collided with the target. And if it collided with the target, then I add a reward, a big fat reward of 1. And then I end the episode, and another training session begins. So the script, you know, is pretty easy. This is the training that happened. So, you know, when you have the ML agent to do training, you basically have to open up a an environment window. I'm using like Anaconda. So I opened up an Anaconda terminal, and then it's I had an ML Agent 16 environment where I installed the ML Agents Python library. So the command I use to start the training is mlagents learn avoidholes yaml force. I use the word force because, you know, of course, as I was doing all the trainings, I had to overwrite the past files that I had created, the past neural network files that were created. And avoidholes YAML was a way that I could like set configuration settings for the Python library training. And this is my avoidholes YAML. This is my training configuration file that I kind of created. So, you know, I have the name of the brain. So you can see here the behavior parameters. The behavior name was avoid holes. So here in my training configuration file, I actually named the training configuration file avoid holes, and I placed that file in my assets folder. All right, so the trainer type was PPO, and I did all these settings here, which most of them I just copied from the basic.yaml that came with the ML agents install, and it has all their sample YAMLs. I just started with that, but I wanted to change 2 things for sure. I wanted to change the maximum. Oh, I didn't even change the maximum steps, but here I could change like the max steps. So that's how many episodes it goes through, I think. So here it was like 500,000, but if I wanted to put, I could put a 0, and it could have infinite amount of steps. That means the training will just keep happening, you know, forever until I stop it. Then there's another thing here, like the number of hidden units and the number of layers. That's how complex the neural network will be. So sometimes if you have, you're trying to train an agent that's doing something more complicated, it helps to let the neural network be a little bit more complicated, like to have more hidden units between the output and the input, and then to have more layers of that. So that kind of sometimes helps if your training's not going too well, to increase the complexity of the neural network. And there's a bunch of other settings, but anyway, this is my first time that I tried using my own YAML file. And what else could I say about this? Oh, I guess my next step would be maybe trying to make it that it could jump over the holes, because I know that sometimes when the training was happening and the target, maybe it was like on an area that was not reachable because there were holes all around it, and there was no way the agent was going to be able to succeed. And I'll still try to go there, and it'll fall in a hole. So maybe on the next one here, I can increase the complexity of this training scenario by having the agent have the ability to jump over a hole. And maybe that's what I'll do next time. I don't know.
You made it to the end of the video. I'm so proud of you. This is my website. The main thing I want to show you is that for any of these videos that you've seen on YouTube, I have the tutorial section, which has the blue links for the projects, and the orange links are the files. Also, you could go over here and play some of the games we made in the game camp.